So there's the formula on the bottom right-hand side of this screen. Does anybody have any questions from page 17 or 66? Take a look over your work. Make sure you don't have any questions. Go ahead.
7E or 17?
Can you say that again?
7E, sorry.
Okay. And I did only assign A, B, and C, but I want to talk. That's okay. I do want to talk about E and tell you why I didn't assign it, because there's something here. There's something good here, but I just didn't want everybody to have to worry about it overnight. What's the relationship between the y-intercept of your formula, y-intercept of the graph, and your formula found from part B? So when you find the formula here, you're going to load in 5 for T1. And, you know, this is one of the crappiest graphs I've ever seen, because I don't think it's too easy to read exactly what those terms are. It's not something that would appear on an exam, be very clear. But I'm looking at this, and I'm seeing that the sixth term appears to be bang on 20, and with a little bit of problem solving, yuck. To go from 5 to 20 is 15. With a little bit of problem solving, I believe the common difference is 3. It's not, they didn't make my life easy in giving me that graph. So if I gave you the graph, I would have had a line every one. I would add 1, 2, 3, 4, 5, and then you could see that it's exactly at 8. Anyway, when you find the equation, you end up with Tn equals 5 plus n minus 1 times 3. And you didn't ask about the first part of the question, so I'm not going to spend time explaining this. You're going to end up with 3n plus 2. That's what you're going to end up with. Am I right? That's what you got. Question D, and I know you asked about E. Question D is saying, what's the relationship between the slope of the graph and your formula? And the answer is, this is the slope. This goes back to y equals mx plus b, where the coefficient of x is the slope. And since we don't have x and y, we have n and tn, the coefficient of n is the slope. Question D is saying, what's the relationship between the y-intercept of this graph, which I think is kind of a bogus, I said bogus, it's kind of a bogus question, because there is really no y-intercept of this graph, is there? Because n can't be 0. But what they're saying is, if you extended this, if you were allowed to extend this to see a y-intercept, what's the connection between the mathematical y-intercept and your equation? And the answer is that this is the y-intercept. It's just, that's a B, not an H. It's just trying to get you to see a connection between this and y equals mx plus b, which is a linear function from grade 10. But I get D. D makes sense to me, that we can talk about a slope of this line, even though it's not a line. But I think as soon as you start to refer to a y-intercept, you're stretching belief. How can you accept a y-intercept when there's no point there? Anyway, have I answered your question? Okay. Any other questions? Okay, so before we go on today, we're going to be looking at some more complicated applications of arithmetic sequences today. But before we go on today, tomorrow in seminar, we're having a quiz on basically what we've learned to begin with. How do you find a common difference? How can you recognize a sequence as being arithmetic? How can you use this formula? So, you know what I'm saying is, that's a question that I would ask you on the quiz tomorrow. This is a question, well, you know what? I don't think I'm going to give you on the quiz tomorrow any problems that have y's or x's in them. They're just going to be problems that have numbers in them. Okay. I think this is too simple for a quiz, quite frankly. However, I might give you a sequence is defined by 5n plus 2. What's the common difference and what's the third term? Stuff like that. Or, like I said, I want to go back to this one. This is a really good question. Another really good question that I would expect you to be able to solve on the quiz. There's got to be one here. Is something like this. And my advice to you is you solve this question without using the formula. You say to yourself that to go from the first term, I'm not even going to write T1, to go from 5 to 4th, 1, 2, you have to add 1, 2, 3 common differences to get 17. And the way I look at this is once you've solved this equation for D and you know that D is 4, you've cracked the case wide open. You could find anything about this sequence now that you know the common difference. And by the way, I don't have to tell you the first term is 5 and the fourth is 17. I could have said the 7th and the 10th. That's a good question. The 7th term is 5 and the 10th term is 17. Well, to go from the 7th to the 10th, you have to add 3 common differences so you can find the common difference. And on a quiz, I might give you this and say, what's the 20th term? So you can find the common difference and then work forward to 20. Anyway, our seminar is roughly 25 minutes long. It'll probably be 4 questions. And if you happen to get them done in that quiz time, then you can continue working on anything that was assigned today. All right, we're going to move on here to the next lesson. This is on page 6 of your unit handout. If I can get you to turn to that page, please. And I don't know how to describe what we're doing today other than to say, now that you know the basics, we can start to see if you can solve more complicated problems. Okay? That's really what it boils down to. The first question here, there's no prelude to this. We're just going to get into the examples. This is a classic example. It is something you will see. I'm not going to put this on the quiz tomorrow. But so everything up to now can be on the quiz. But this is something you'll see on the unit exam for sure. And this is actually a good example of part of a written response question, which means you have to be able to find the answer to it algebraically. You have 3 terms, and they have x's in them. The first term is 3x plus 2. So I think it's a good idea for you to write these out in sequence in order to understand our approach here. And the second term is 17, and the third term is 10x minus 7. And what you're told is that this is arithmetic in nature, which means there's a common difference. And the question is, what's x? Find x. What's the number that you would put in for x that would make this arithmetic? So, this is not what you would do, but I want to make sure you understand what the question is asking. Maybe x is 2. Maybe x is 2. If x were 2, and you're not writing this down, this is just me thinking out loud. Is x equal to 2? Well, if x is equal to 2, then 3x plus 2 is 3 times 2 plus 2, which I believe is 8. Help me out here. It's 8. And if x is 2, well, this is 17. If x is 2, then this would be 10 times 2 minus 7, which, help me out, is that 13? 10 times 2 is 20. 20 minus 7 is 13. So look at the sequence of numbers I've generated and tell me, is x 2? Well, no way, because 8, 17, 13 is not arithmetic. To go from 8 to 17, you add 9, I believe. And if I added 9 to 17, well, I'm sure as shooting not going to get 13, right? Well, that's not how you're going to solve the problem, because then you'd just be poking around in the dark all day trying to find a number that works. And if this were a written response, that wouldn't be acceptable. So I don't know that anybody, without being told how to start, has an idea. Maybe you do. I don't want to always just show you how things are done. I want to put it out there and see if anybody can come up with a possible strategy that you think might work. So does anybody have any ideas on what we could do here? And the hint I'm going to provide is this. That the common difference can be found. The common difference can be found by taking the second term minus the first term. That gives you the common difference, right? It can also be found by taking the third term minus the second term. And if it's arithmetic, then when you take the second term minus the first term, you'd better get the same thing as when you take the third term minus the second term. Right? So I'm starting off with this idea that T3 minus T2 has to give you T2 minus T1, because both of those are legitimate ways to calculate the common difference. Right? Now, normally what we do is you would take T3 minus T2 and you'd figure out a number, but we don't have a number, do we? Because there's an x there. But we can still write 10x minus 7, that's T2, minus, whoops, that's T3. I'll put it over here, my mistake. That's T3 minus 17. The common difference is 10x minus 24. I don't know what that is, but we're about to find out. And that has to be equal to T2, which is 17, minus T1, which is 3x plus 2. So before I go on, and by the way, there is a mistake on the board that I've put there intentionally, and we'll get to it in a second. Does this idea make sense to you? That the third minus the second term is the common difference. The second minus the first term is the common difference. So the third term minus the second term has to be the same thing, equals the second term minus the first term. And I want you to notice that that leads us when we put in, I'm going to run out of colors here, but that's okay. When I put in the first term for T1, in fact, I'll get rid of this stuff. So there's my minus T1. Let's see. Here's my T2, and I have to put T2 here and here. That's why I got 17 here and here. And I'm going to make it. Let's see, what else we got? Green T3, which is this, has to go here where I subtract T2. Do you get the drift of what I'm getting across here? If you know the colors are bothering you, ignore the colors. But so does that equation make sense to you? So from a purely mathematical standpoint, we have an equation with x in it. It's possible to find x. But I have purposefully put a mistake in that bottom line. And it is a mistake, if I'm being honest with you, that I was making in high school into grade 12. And a teacher finally looked at me and said, "What are you doing?" And I said, "Well, I'm subtracting." And she said, well, she explained the problem to me, and I was making the mistake all along. Nobody ever bothered to point it out to me. And you might be in that boat too. What is the problem with what I've written? I've written something wrong. Thomas knows? Go ahead. That's right. I need to include brackets around 3x plus 2. I have to subtract the first term, 3x plus 2, which means I have to subtract all of 3x plus 2. I don't have to subtract 3x and then add 2. Turns out I have to subtract 3x and I have to subtract 2 because they're both things that are included in what I have to subtract. And this is a very basic math idea, everybody. This goes back to maybe even grade 7, probably grade 8 and 9 for sure. And there are all kinds of ways for you to handle the algebra here. So how many of you remember being taught this, and this is what you like to do? You put a 1 here, and you multiply that negative 1 through. Anybody remember that? Okay. So if you did that, this becomes 17 minus 3x, and negative 1 times 2 is minus 2. That's legit. You could do that. How many of you remember being taught the second thing, which is not what I would do? I wouldn't do the first thing that I've shown you, and I wouldn't do this next thing. How many of you remember being taught that when you're subtracting something in brackets, you remove the brackets and switch the sign of everything inside of the brackets? Okay, so if you do that, then you get rid of the brackets and the positive 3x becomes negative 3x and the positive 2 becomes negative 2. You have to decide on something that's going to take you there. This is what I do. I'm subtracting 3x plus 2, which means I'm subtracting 3x and I'm subtracting 2. How many of you kind of think that way? You got to pick something. You got to find a way to handle that. What we have then is 10x minus 7 minus 17 equals 17 minus 3x minus 2. By the way, you never need brackets here. The green brackets, I'm going to say, are never needed. You never need brackets on the thing that you're subtracting from, ever. Okay. Do you need brackets on the thing we're subtracting here? Yes. Do you need brackets here? No, because it's a monomial. It's one thing. But if you just get in the habit of saying, whenever I'm subtracting, I'm going to put brackets around the thing I'm subtracting, you'll cover your bases. You don't always need them, but if you never put them, you're going to make a mistake from time to time. It's not a difficult equation to solve. It's what we call a linear equation because it's just x's and numbers. We can simplify this to 10x minus 24 because negative 17 and negative 7 are like terms. Here we have a negative 3x, and then 17 minus 2 is 15. And now I'm going to explain to you the Paul Way method of solving a linear equation. I'm just not a big fan of doing this. I mean, if you want to do this, you can. I don't care. Honestly, what I care about is at this level, everybody can come to a conclusion here about what x is, showing even a limited amount of work. Now, here is what I would write. This is what I would write. And what I'm doing is I'm collecting all of my x terms on one side of the equation. I'm moving anything with x to one side, and I'm moving anything without x to the other side. And I always want to try to arrange a positive number of x's. I don't like having negative x's. So when I look at this, I see positive 10x on the left and negative 3x on the right. So that tells me I want to move them to this side. And I suppose I am really adding 3x to both sides. But the way I look at it, and I think this will be helpful for you, is when you move a term, which is what all of these four things are, across the equal sign, it switches signs. It's called transposing. I transpose the negative 3x to the other side where it becomes positive 3x. And that's where I get the 13x from. On the other hand, I got to bump this negative 24 out of the way because this is where my x's are going to go. My 24 is negative. I transpose it to the other side where it becomes positive, and 15 and the 24, positive 24, give me 39. And I really hope that that discussion and then the statement that x equals 3 is one that you're just looking at going, well, yeah, obviously, this is all true. Because this is a very basic equation to solve at this level. The 3 or 4 minutes I've spent explaining it is something that maybe many Math 20 teachers wouldn't even spend. They just go, we solve this equation, we get x equals 3. And that's where I will be in a few days with you. I don't think we need to spend time teaching how to solve this. You need to know how to solve it. Now, if you have difficulty, I'm willing to help you always, but I'm not going to go to this level of explanation in going from here to here every time we have something like this. So x is 3. That's the answer to the question. Now, we can certainly, well, it's not quite the answer to the question, but let's say the question did just say find x. How could we check our work here? Well, you would put the x value you got every place there's an x. And if I put, and I know you're calculator-oriented people, but try for simple numbers not to rely on a calculator. If I put 3 in here, what does this mean? It means I have to take 3 times 3 and add 2. Well, 3 times 3 is 9. 9 plus 2 is 11. So this is saying the first term is 11 if x is 3. The second term you're already told is 17, and looking at these numbers, looking at those numbers, you can see a common difference of 6. So the third term better be 23. Is that right? 17 plus 6 is 23. Okay, so if we put x equals 3 in here, 10 times 3 is 30. 30 minus 7 is in fact 23. So it works. The true answer to the question is x has a value of 3, and the first 3 terms are 11, 17, 23, and you're also asked for the common difference. The common difference is 6. Any questions with the first example? This is a question you need to familiarize yourself with. Number 2, the third term of an arithmetic sequence is 30 and the 10th term is 114. Find the first term and the common difference. Okay, now just a second here. If it weren't for this statement, you already know how to answer this question. Okay, this is a quiz question, and I want to go through how you would solve it if you had a choice. What you would do is you would say 1, 2, 3. So the third term is 30. And the 10th, 4, 5, 6, 7, 8, 9, 10. The 10th is 114. And I do realize some of you don't need to resort to writing a whole bunch of blanks. Well, I'll ask this question. How many of you know, without looking at those blanks, how many common differences, oh man, I'm going uphill there. How many common differences you add to the third term without looking at the blanks to get the 10th term? Kai, do you know? It's actually 7. And we know there's that extra 1 sometimes when we count stuff. But from 3 to 10 is 7 leaps. If I'm on the third stair and I want to get to the 10th stair, I have to walk up 7. I have to go 1, 2, 3, 4, 5, 6. I have to go up 7. Okay, so let me clean this up a bit. When I said many of you know how many common differences, and it is a tricky thing, it's not an easy thing. Definitely not an easy thing. Most people can't do it. Sometimes I have to draw the blanks. So you may have to draw the blanks here to see that it's this. Okay? Are you with me so far? Okay. Here's where the problem comes in. What if I told you it was the 7,015th term? I don't think you want to draw blanks, do you? That's a lot of blanks to draw. So anyway, this is how you would do it if you had a choice. You would say that to go from 30 to 114, you're going to add 7 common differences. And I would like everybody to solve this equation for D. Which would involve taking 114 minus 30 and then dividing by 7. I want to say 12. Is it 12? Okay. So then what you would do is you would say, well, okay, the common difference is 12. Oh, I've been asked to find the common difference, so I got that. Then it says, what's the first term? So what I would do is I would just go, well, if I take 30 minus 12, that gives me the second term. If I take 18 minus 12, that gives me the first term. Two things here. Is my arithmetic correct? Those numbers are right. Secondly, does that ring true to you? That makes sense what I did? Okay. So this is how you would solve this problem on, say, the quiz tomorrow. And I might give you this information, and instead of saying find the common difference in the first term, I might say what's the 7th term. But you could figure it out once you knew the common difference. So we're okay with that? So I am about to show you how to solve this using a system of equations, a system of linear equations, even though it may seem like more work, because solving a system of equations is an important concept in Math 20 and Math 30. We're going to, almost in every unit, we're going to have to solve a system of equations to solve problems. The problems we solve cannot always be solved by drawing blanks and reasoning it out a different way. You have to use a system of equations. So let me write out the general term formula. Tn equals T1 plus n minus 1 times d. And I want you to note that in order for us to crack this problem wide open, you need to know this, and you need to know that, right? No, we know them because we figured it out in a simpler way. But let's pretend we don't know them. This is what the problem is. So we have those two unknowns we have to find. And normally what I would say to you is that in order for you to find something else that's missing, you need to put in a pair of numbers for everything else. Okay, so for example, we know that when n is 3, Tn is 30. Right? Those two go together. Let that sink in. Those two go together. When I put 3 in for n, I have to get 30 for Tn. They go together like peanut butter and jam. They're locked together. What happens if I put those in? I get 30 equals T1 plus 3 minus 1 times the common difference. Are you with me? I'm going to simplify that by writing 30 equals T1 plus 2D. Okay? And I'm going to ask you to think about this question. Why can't I solve that for D? Why can't I just rearrange that for D and figure out the common difference? I mean, we want to find the common difference. There's an equation with the common difference. Why don't I just rearrange it and figure out what D is? So who can tell me why that just doesn't work? Adriel? Can you repeat that a little louder, please? Right, there's more than one unknown. The bottom line is, I don't know T1. So I can't rearrange that for D because I don't know the value of T1. In Math 10, and this was the last unit you studied in Math 10, you learned about systems of equations, and you learned that if you have an equation with two variables, as Adriel's saying, or two unknowns, then you need two equations to accomplish the solution. You need two equations to find out the values of those things. We only have one. Where am I going to get the other equation from? And I would ask you to think about how I got the first equation. How did I get that first equation? Well, I put in 3 for n and 30 for tn because the third term is 30. Anybody want to take a shot at how I can write out the second equation? Yeah. Perfect. We also know that the 10th term is 114. And these two go together. Whenever we put n equals 10 in, we have to get 114 coming out for tn. And that means when we load that into this equation, we're going to get 114 coming out. It's equal to T1 plus 10 minus 1 common differences. And we can clean that up and write 9D. So we have 114 equals T1 plus 9D. Now, keep in mind again, I'm doing this with you not because I think this is the most efficient way to do it. I think this is more work than is necessary. But I'm trying to review a set of skills from grade 10. It's really important. Let me highlight the two equations. You don't need to highlight them if you don't want to. I'm just highlighting them to make a point. This is one of the equations in simplified form, and this is the other equation. So what I'm going to do is write them together outside of this mess. I have 114 equals T1 plus 9D, and I have 30 equals T1 plus 2D. How many of you remember, and I know the past couple of years have been a whirlwind, how many of you remember vaguely what a system of equations looks like? Kind of. If I wrote this, would that be more familiar to you? A system of equations is two equations. It can be more, by the way, but in high school we typically use two equations with two different unknowns. Your goal in solving a system of equations is to get rid of one of the variables. What can we do to these two equations to get rid of one of those two different variables? Do you know?
You would solve for T1.
Okay. So one of the things you could do is take, let's say, this equation here, the bottom one, and rearrange it for T1 to get T1 equals 30 minus 2D. And what would you do with this 30 minus 2D? Boom. And you would be using the method of substitution. Now, I notice you're not writing this down, and that's good because you have to make a decision here. If you want to do it that way, we can do it that way. But if you did do it this way, then you would end up with 114 equals T1 plus 9D. And forget about proceeding here. Do you see that you could find D now? Right? It's possible. I'm going to do it a different way in a second, but I want to finish your solution for us. Okay? If I simplify this, I have to subtract 30 from both sides and I get 84, do I not? And then I have negative 2d plus 7d. Oh, that should look familiar, shouldn't it? Isn't that what we were doing before? When you divide both sides by 7, you get d equals 12. Once you know the value of d, how would that allow you to find the value of t1? Right. You would go back. I suppose. Oh, actually, you're right. If you knew t1 was 12, you could just work backwards. But algebraically, you could put d equals 12 in here, couldn't you? You could go 30 minus 2 times 12. That's one way you could do it. I'm going to do it a different way. And I'm going to ask the question again. The question is, we were right here. So I haven't erased your work. I've got it on a different page. The question was, is there a way for me to get rid of one of these variables using these two equations? And there's a very quick, slick way to get rid of t1. Kai, just subtract the equations. Now, sorry, I have to look. Sasha, right? Sasha's method is called the method of substitution. You rearrange one of the equations for a variable, and the variable you chose was t1. You put the result into the second equation. That's called substitution. Does anybody remember the method that we're using here, what it's called, when Kai says, well, let's just subtract the two equations? It's called elimination. I mean, they both eliminate a variable. Sasha's method eliminates the t1, and this eliminates t1. But look how quickly we eliminate it. 114 minus 30 is 84, equals 7d. Oh. So this is there's nothing wrong with your approach. But sometimes substitution is a little bit more work than elimination. And this is a case where that's true. That being said, you want to do whatever works for you, always, for anybody. So when I divide both sides by 7, I get d equals 12. Now, how do I find the first term? I mean, I could go back to my blanks, but I'm trying to show this to you in a more general sense. I would take one of the equations, which is 30 equals t1 plus 2d, and I would put d, which we found to be 12, into that equation and solve for t1. So I'm trying to show you an algebraic approach, an equation approach, rather than a blank approach. So we would have 30 equals t1 plus 2 times 12. 2 times 12 is 24, so when you subtract 30 minus 24, you get t1 equals 6. I'm not going to finish the rest of the question. If you want to find the first term, then you can subtract and subtract. Oh, we already have the first term, 6. That was it, right? Any questions with that? We're good. So I do want to make a point here that this is not, this is an algebraic approach, but this is also Math 20-1 where it's algebra based. So I have to help you build those muscles early. This is not how you would do this problem if you had a choice. You'd do the blank method. All right, let's take a look at a couple more. Number 3, the last two problems are just word problems. And the problem that students have, the difficulty with word problems is you have to take words and turn it into math. And that means you've got to sift through all the crap because a lot of the words are meaningless. They don't really mean much in terms of the math. And you have to change the question into a mathematical description. So a visual and performing arts group wants to hire a community leader. Who cares? I mean, it's part of the question, but I don't care what the purpose of the group is. There's somebody who's going to be hired. That's what I get out of that first sentence. And the pay is going to be $12 for the first hour. And it's going to be $19 for 2 hours of work. This is an admittedly weird way of paying somebody. This is not saying they're going to get $19 an hour for 2 hours. They're going to work for 2 hours and get $19. Which is a bit of a ripoff, isn't it? Because for 1 hour they're getting paid $12 and they work 2 hours and they only get 19. But community groups often pay people like that because community groups often get volunteers that don't get paid at all. But in order to entice the volunteers into agreeing, they give them this decreasing hourly wage, really is what it is. $12 for the first hour, and then I want you to understand here, if they work for 2 hours, they're only getting $9.50 an hour because it's $19 for both hours together, not for each. And then for 3 hours of work, it's $26. When you look at those numbers and you look around at what we're doing, we're talking about arithmetic sequences. Do those numbers form an arithmetic sequence? Yeah. So what we could do is take 12, 19, 26, and we could say this is n and this is tn. 1, 2, 3, 12, 19, 26. But you need to understand that this column is really the number of hours, and this column is really the amount of money. That's all. Everything we do with this formula that I'm going to show you on the right-hand screen again, we do with those numbers. It's just that we remember n as a number of hours. It's not just a term number. And Tn is a number of dollars. It's not just a term value. So write the general term that you could use. Quite frankly, once we get to this point, this is a yesterday question, where we put T1, which is 12, and D, which is 7, into this formula and simplify it. And, you know, I really hope the reason why not many people had questions about the homework is that you get it. You can do this. Because if you're sitting here right now, if you're the person who's sitting here and you're going, I didn't really figure out how to get this, but you were afraid to ask, that doesn't do you any good, right? So I'm really going under the assumption here that everybody can put this in. And I guess you know what? I'll find out tomorrow on the quiz, won't I? So this is going to be Tn equals 12 plus n minus 1 times d, and d is 7. Give you just a minute here to simplify that expression. I'll put the 7 in brackets, although I don't really need to. Give you a minute to simplify that, multiply the 7 through, collect the like terms. And that's what I get. You know, and again, I really hope that in the time I was saying, oh, I'll give you a minute to do this, you guys already had the answer, many of you. 7 times n is 7n, 7 times negative 1 is negative 7. And then I have 12 plus 7n minus 7. There you go. There's the answer to the question. The answer to A. What will the person get paid for 6 hours work? Before we actually answer that, and I know it's not a difficult question, but I also know, because I've been doing this a long time, that people get confused between n and tn. They get that mixed up. When you look at question B, the question is giving you n equals 6 and asking you what tn is. When you look at question C, the question is giving you tn and asking you what n is. And we solve problems at this level with algebra. We have a formula that we use. The formula is, God, I'm embarrassed to admit I think I forgot it. 5 plus 7n? Is that what we got? Okay. 5 plus 7n. So in B, we put 6 in, and this is our answer. That's what comes out. In C, we put 166 in, and this is our answer. And no matter how you cut it, solving this equation for one of the variables when you know the other is grade 9 math at best. Like maybe it's even grade 8 math or 7. This equation becomes Tn equals 5 plus 7 times 6. Oh man, a counting horse could do this question because you don't even have to rearrange it, right? There are horses that count and do arithmetic. You can look it up online. 5 plus 7 times 6 is 47, I think, but I just want confirmation. 47. So the answer to B is 47 clams, dollars, simoles, whatever you want to call it. And B or C, we have 166 equals 5 plus 7n. I think my horse might lose interest in this problem because it involves rearranging, but you have to subtract 5 from both sides and divide by 7. And I want to say you're going to get, I don't know what you're going to get, 161 over 7. I couldn't tell you. My brain has just shut down. 23. So 23 hours. By the way, we had to get a natural number here. You couldn't get any decimals when you find n, because n is an integer. Well, it's a natural number. It's 1, 2, 3, 4, etc. Any questions with that example? All right, final situation. Somebody is going to stack, well, Jonathan has a part-time job at the local grocery store. Who cares? Who cares that the person's name is Jonathan? Who cares that it's a grocery store? Want to create a display of cereal boxes. Okay, yeah. Oh, here comes the meat of the sandwich. The top 6 rows of the display are shown. The number of boxes in the rows produce an arithmetic sequence. You can see that, right? If you start at the top, you add 2 boxes each time. If you start at the bottom, you take away 2 boxes each time. This is an important idea, everybody. If you're going to call the top row T1, I'm not saying we're going to, then D is 2. If you're going to call the bottom row T1, then D is negative 2. And we are going to have to call the bottom row T1. And by the way, the bottom row is not shown. This is just the top 6 rows. There's more rows. The reason why I need to call the bottom row T1 is because of this statement. It says the third row from the bottom contains 16 boxes. And that means that I can write T3 equals 16. Because I'm counting from the bottom, and it's the third row from the bottom. If I count from the top, I don't know what row number that is, because I don't know how many rows there are down to the third row from the bottom. This other statement says T8 equals 6. It's kind of a sneaky setup. But you should note that this question is one you already know how to do now. This, if I say the third term is 16 and the 8th term is 6, you should know how to solve this problem. You can solve it the hard way with a system of equations, or you can say this. And I don't have a problem with drawing blanks. 1, 2, 3, 4, 5, 6, 7. Sorry, I don't know what that is. I guess that's supposed to be a comma. 1, 2, 3, 4, 5, 6, 7, 8. We can find the common difference from that. And from the common difference, we can figure out whatever we want. A question for you. How many of you know you add 5 common differences without drawing the blanks? You're looking at these two numbers, 3 and 8, and you're saying to go from 3 to 8, I have to add 5. And don't psych yourself out by going, oh yeah, but do I count the first one or not? To go from 3 to 8, you have to add 5. If I have $3 in my pocket and I want $8, I have to add 5. So I think I've mentioned this, but if not, I mentioned it a lot, so it won't be the first time. I'm a huge fan in high school math at taking something that's at this level and turning it into something that's at this level. We've just gone from, after we've deciphered the problem, something that is a Math 20 idea, right? And we've turned it into, let me rewrite that so it's a little clearer. We've turned it into kind of a upper elementary, early junior high question. What value of D makes that true? I'm not saying a grade 5 student necessarily knows how to rearrange it, but if you gave them Smarties, they could figure it out. And I don't just mean give them Smarties as a reward. I mean to count with, okay? Subtract 16, so you get 5D equals negative 10. And I know that we're running in circles here because you should already know D is negative 2, right? And look at the diagram. But if you didn't know that, if I just told you that Jonathan, whoever it was making a stack of boxes, and I told you how many boxes were in the 6th and how many boxes were in the 3rd, or whatever the numbers were, you'd have to do this to find D. Anyway, D is negative 2. Which, again, we already knew. We didn't need to do all this work. But that would mean this is 14, this is 12, this is 10, this is 8, this is 6, jackpot. It matches what we should get. This would be 18, this would be 20. We can answer the question now. The answer is, was it, how many in the bottom row? 20. I mean, there's certainly a puzzle-like approach you could have taken. You could have started drawing this and expanding it until you got 16 and proceeded from there. But I think that's overkill. What's the general term for the sequence? I hope everybody is starting to see a recurring theme. This is stuff we learned how to do yesterday because, again, I don't know why I wrote 6 there. It's negative 2. I think I'm stuck on the previous question. All we have to do is load that into the general term. So this time, what I'm going to do is ask everybody to load in D and T1 and simplify it while I walk around the room. When you have it, circle it in your notes so I can see what it is. And if it's right, then you can get started on the assignment. And you have about 20 minutes today to work on that.